Hi, everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human Centric AI podcast, where each episode we interview thought leaders doing cutting edge work in the AI space. A little bit about us. For over 20 years, SmartEye has developed AI in the form of eye tracking technology that understands, supports, and predicts a human's intentions and actions. By carefully studying eye, facial, and head movement, our tech can draw conclusions about a person's awareness and mental state. Our eye tracking is providing new insights for research within aerospace, aviation, neuroscience, and more. Today, we feature our own Emil Rolander, Customer Success Manager at SmartEye, discussing the journey of success with SmartEye at your side during a recent webinar. In our conversation, Emil and I walk listeners through the integration process post-purchase, shed light on the collaborative experience in working with our dedicated team, and expose some of the lesser-known values of our Smart Support. Let's listen in to learn more. Welcome. Thank you all so much for joining us for today's virtual event. Congrats on your new eye tracking system. Now what? Maximizing success with SmartEye Solutions. My name is Ashley McManus. I am the Senior Director of Global Marketing at SmartEye. I just wanted to give some brief context as people are arriving, and then we're going to talk more in depth about this. Today, we are going to dive into all things customer support at SmartEye, walking you through the integration process post-purchase, shed some light on the collaborative experience working with our team, and share more about the value of Smart Support. We will also touch on that, even though our eye tracking systems are comprehensive, setting them up and working with them doesn't have to be daunting. We know that the success of our customers with our cutting edge tech is dependent on the support and the guidance that we give them. So just a few housekeeping items. If you have questions, please do drop them in the Q&A, the chat function on the right-hand screen of your screen at any time. This discussion will be about 20-25 minutes or so, and I will field any questions we might have to our expert during that time. So please don't hesitate to ask anything top of mind. If we don't get to your question or you think of something later, you can always reach out to us at any time via email, and we are happy to chat further. So with all of that being said, I am thrilled to host our expert speaker today, our own Emil Rolander, Customer Success Manager at SmartEye. Emil, did you want to briefly introduce yourself before we get started?
Yeah, sure. My name is Emil Rolander. I live in Sweden. I've worked for SmartEye for, I would say now, 6.5 years or so. Fun all through these years, and I'm here and doing support and commissionings and handling everything that have to do with the tech side of what the customer meet and what we're supposed to be talking about for the next 30 minutes or so.
Awesome. Great. So wonderful to have you join us today. So let's get into it. For those of you who are unfamiliar with SmartEye, I thought I'd give a super brief company overview, starting with the story behind SmartEye's inception. It all began with a dream. Mats Krantz, father of our CEO Martin, envisioned a world where his wife, who was suffering from a frozen shoulder, could control a computer using only her eye movements. So this dream really laid the foundation for SmartEye. And then Martin, after careful consideration, turned this dream into reality. So today, SmartEye is dedicated to bridging the gap between humans and machine, just as Mats had originally imagined. So next slide. At SmartEye, we've developed the most advanced camera-based software system to track head, eyes, face, emotions, and more with unparalleled accuracy. And everything that we do is really centered around understanding the most intricate system in the world, the human being. Our vision is to really leverage this understanding in order to better support human behavior in complex environments. And just to give you a sense of our size, so for over 23 years, SmartEye has grown into this global AI powerhouse. From a really small team of about 7 or 8 people, we've expanded to over 300 employees, with our headquarters still based in Gothenburg, Sweden. The SmartEye Group has also established 2 subsidiaries, Affectiva and iMotions, with offices worldwide, including Boston, where I am, Ann Arbor, Cairo, and Copenhagen. So we really are we're not just pioneers, we're leaders, right? So Smart Eye is the market leader in providing driver monitoring systems for serial production car programs, making roads safer for everyone. Additionally, we do provide sensors and solutions for multimodal behavioral research, and sharing our tech is at the forefront of understanding human behavior. And our expertise really extends across 5 key business areas. So we have automotive solutions, applied AI systems or AIS, research instruments, media analytics, and behavioral research. We won't go super deep into each of these business areas today, but each one is really essential to our mission of bridging this gap between the human and machine. And we're constantly innovating in each sector. And some of our market stats and customers that we've worked with. So Smart Eye has been chosen by the world's leading companies and research institutions for our groundbreaking tech. To date, we've actually secured 320 design wins from 21 global automotive OEMs, so original equipment manufacturers, with over 1 million cars equipped with Smart Eye DMS on roads today. Affectiva is trusted by 90% of the world's largest advertisers and 26% of the Fortune Global 500. And then iMotions is utilized by more than 1,300 research brands worldwide. So I believe that is a sufficient company introduction. It is now my pleasure to hand it off to Emil, who will get a little more technical with us and take us through what you can expect in your customer support journey. So Emil, perhaps you can touch on the Smart Eye Pro product and we can take it from there.
Yeah, absolutely. I mean, there's no way around talking about the support and what we do at support without actually understanding a little bit of the product that we actually do support. And research instruments, mostly it's about multi-camera system. And what that means is you see a picture there in the yellow. That's one of the cameras with its attached beam. It's maybe a little hard to get the grasp of the size. So I actually brought a camera and holding it up here. So you can see I'm actually holding the camera. This is the size that we are using. So the form factor of the camera is one element of why it's easy to integrate it into any environment. I mean, the smaller it is, the easier it is to actually make a good placement of the actual camera. Because it's obviously, in the end, it's fairly important that we get a position where we see the face and essentially the eyes. So it have to be placed in the environment in a way that when you rotate into the image or out of the image, the camera obviously needs to see you. And I mean, there's a lot of different eye trackers out there, but most of them, I would almost dare to say all of them, is built on the fact that you have one camera that tracks your head and face and eyes, and that is doing the tracking of mostly a screen, and a lot of times a fairly small screen. But with the fact that we utilize multiple cameras, more than one cameras, we can actually adapt to more or less any environment that you can think of. And I mean, here the complexity comes in, because the more cameras you have, the more they have to work in relative to each other. So what began, 25 years ago, as you said, and actually next week, I think 17th of May, we have a grand party celebrating the 25 year of actually being here and doing this. And I mean, doing one camera, a lot of companies can do that, but doing more than one camera, that's the hard part. And that's where we come in. And we have practiced this, and we took a route that is harder to begin with, because what we actually do with the tracking system is we track the head, and from the head we find all the other facial features, so nose and ears and mouth, but then we find the eyes. And when we find the eyes, we do what we call an eye clip, and we find where the pupil is inside the eye clip. And in relation to like how the pupil is turned within the eye, and since we know where the head is within the head box, we can follow this movement. So it's not only an eye tracking system, it's also a head tracking system for that sense. And a lot of other eye tracking companies out there doesn't utilize that feature of also knowing where the head is. Because the fact is, if you have a complex environment, you need to be able to, even if you're driving a car or an airplane or whatever you do, human behavior, since we actually have a neck and a head, we can actually rotate the head a lot. we want that field of view to go in and out of each camera. So if we want to look up or down and side to sides, if we only had one camera looking at us, it wouldn't really work that well. So by talking to the customer and realizing, okay, how much eye movements or head movements do you expect this situation we are constructing to do? So we can do up to, I would say, 8 cameras. That's a lot. And that also gives us the more or less full field of view that we can actually rotate 360 degrees around any rotation. And if we don't need to go all the way back, which is kind of like not that common, we can do up and down instead. So the more field of view we need inside the environment, that's what makes it remote. So you never have to have like wearable glasses or a helmet or anything. The idea is you should just be able to sit down in the environment. We track the head and the eyes. And whatever you do as a subject, you should never think about, I'm sitting here and I'm being tracked. Let's do no head motions for this study because like I'm an easy target. We are especially designing the system to do the hard cases where you actually rotate and do weird motions. We just make sure that as long as we have cameras placed in the environment, we can actually track that face. And in extension, we track the eyes. So that makes, by just changing the top of the camera, which is the lens, we can place that in different length to the environment. And so we can actually, work more or less in any situation we can get ourselves into.
Awesome. Can we talk about the team a little bit?
Absolutely. Here we have some 4 handsome guys, I see. It's me and 2 of my Swedish colleagues, Peter, Emil, and Sardar. Aaron is in the North American office. He's situated in Michigan, but handles most of both the customer visits and the installations that we do for the North American market. But since that is a pretty huge deal of the total market, US is a big market, we sometimes travel over there to also visit with the customer. But Aaron is North America. Me, I'm more of like a global virus, traveling all over the place. Yeah, exactly. I'm doing all over the place. And Peter and Sardar are doing Europe and Asia most of the time. And I just want to mention a little story about the title that we use, like customer success manager. Sometimes people is like, oh, what is that? Like, because it's a little soft or something. Like, what does a customer success manager do? We actually got the idea from our sister company, iMotions, and I've seen it in some other platforms as well. But the idea is when I started SmartEye, we had 2 different roles. One role was sales engineer and another role was support engineer. And that was like when we did customer visits, we actually went out to the customer, demoed the system and show all the tools and how well it works. And when the sale came, another person from the support team went out and did the actual installation and the education and actually deploying the system. So what we ended up talking about, and I think makes much more sense in the end, is if we are doing everything from the demoing when we are at site, talking to the customer, seeing like what is your need, how do you want to use the data, what are you looking at, and to actually be the same guy coming back to the customer, knowing the site, knowing the customer, you have your chance to set yourself in their situation, what you're actually looking for, and continue that process by, deploying the system, educating the staff, and making sure that the data outputs at the post end works as good as what we talked about during the demo call or whatever that could be. So we wanted to change those 2 roles, get them into one segment to say we meet the customer and we are fully part of the whole process, talking from just the idea phase to the actual deployment. So we ended up doing that swap, and I think it works pretty damn great, actually.
Awesome. Love that. So I'm kind of throwing this at you, and we're not going to read every single one, but we're always trying to get feedback from our customers. And we had a couple of testimonials that I wanted to highlight and share with the group here. And we don't have to go deep into each one, but I saw a couple of themes of, persistence, patience, knowledge, timely responses, ultimately really taking time, as you mentioned, to understand, the customer and their issues. So well done. I didn't know if you wanted to comment on any of that before we keep going.
No, I mean, I guess, I mean, patience is obviously something you need a lot of, especially when you are about to do support for a highly advanced and technical system that has a bunch of complex, difficult nature. If you don't have patience and you're not, you need to love problems, because solving problems can be also very stimulating in that sense. So when we work at support, when we get a question from our customers, and if stuff doesn't work as intended, we can't really see it as like, oh man, this is problems again, every day just problems, because it's not necessarily the way we can look at it, because it's usually just a way to see how do we get this to work for the customer in their setting. And I mean, if you're tech savvy, and I used to refer myself as a nerd in almost every instance, because I mean, I just love technology, and I've been doing that all my life. So when someone comes to ask me, it's like, oh, there's something wrong with my TV. Usually it's enough for me to just like grab the remote, and the TV kind of recognize like, all right, there's a serious guy. He's gonna do this. So it's about, loving technology and finding the root cause of things. And I don't necessarily see everything as problems in that sense.
Yeah, talking about bridging the gap.
Exactly.
So transitioning here. So for those who are listening today who might not yet be customers, or they're thinking about purchasing, can you explain a little bit more? And you did touch on this, how early you begin speaking with customers and
yeah, exactly. So it all depends of course, where the lead or opportunity comes in. But a lot of the times it could be like, we meet someone at a conference, we do talk to a customer about that they have an idea or an interest of like, I wonder if we can use eye tracking to solve this problem, or we need data about designing an HMI display for a car, or it could be literally anything. And to pass from those ideas, of course, we have to see how does that idea present itself in terms of data. Because that's essentially what our cameras are doing. It becomes a sensor, and that sensor presents a lot of data. We have a lot of data. Head rotation, gaze vectors, hitting objects in the 3D world. Like there's like, I don't know, 200 different data outputs that we can give from this sensor. So it all comes down to, what are you interested in? And it's hard to just say over a call or something from a conference to say, you know what, that's enough for me, I'm going to buy it. Because a lot of environments are more complex or advanced like that. So what ends up happening is we travel to the customer and we actually deploy a system on site to be able to show a proof of concept that we can actually do this in your setting. Yeah. Which is important, of course, because it's a lot of money. I mean, it's not a cheap system in that sense, but it's also because we kind of know that this is the best way to go if you really want, a good comprehensive tracking of a subject in an environment. So this is normally a pretty stressful phase, especially when it comes to us tech guys following the sales guys into these meetings, because we have to do what generally maybe takes a day to actually deploy a system. And here we have maybe an hour or 2 or maybe 3 hours to actually toss some cameras up in a car or a helicopter or an airplane to actually show like, okay, this is how it would look. But here it's more the idea of, proving that it works in this type of environment and what they expect.
Mm-hmm. Which is huge. So let's know from here, that's pre-purchase. We're thinking about it. Let's decide to move forward. Great. Looks like it works. Now what? Like what happens with your team and how do you?
Yeah, exactly. So hopefully that the demo and everything went well. And I mean, we find the data to be, answering some of the questions that the customer might have for whatever that might be. Here comes what I think is the absolutely most important part. And for me, thankfully, I find this also to be the most fun part when it comes to the job and role we're doing as, during support. And we call this phase the commissioning and training. So when you buy a system, it could be a 3-camera system or 5-camera system or whatever. When we deploy it in the actual environment on the customer site, it usually comes with a day or two of training the staff. Because the idea, of course, is when we leave and we have deployed a system, the customer or the user should feel comfortable enough to work with the system and day-to-day operating and seeing like, okay, this is the data we want, this is how it looks. And if some minor issue comes up, how does that look? How do we do that? So here it's all about education. And this is where I find, like, first of all these environments that we do visit with the customer, there's like it's theme park or amusement park for me, because like going into all of these moving base sims, there's technology all over the place, because like it's just toys. I love this. So getting our system into their already advanced and awesome technology means that we like combine our different strengths, one company to another. And if I can do this process as fun and easy as possible, that is when I think my role is getting fulfilled the most. Because I mean, there's a way to train someone in eye tracking, and you can do it severely boring. But you don't learn as good if it's boring. So I just want to engage people when we actually deploy it, because there's no use for me just going to a customer, tossing up the cameras and doing the installation. It's like, all right, that's a wrap. Now it works. Bye bye. Because I want them to engage with the cameras and understanding like, why do we position a camera over here, and why do we look at and what are we looking for when we're actually deploying in the system. So that's a very, very important phase for the customer to feel comfortable with the actual product after the purchase. So I mean, without that, there's so much that can go wrong. So here is actually where the support of a purchase actually starts. So this handover from me as a support engineer, almost learning them by doing it, and how do you now live with the system. That's very important for me at this stage.
Mm-hmm. Absolutely. And I remember us talking about this in the past too, and your process and how you think about it. It also is very empowering, right? So you're working with them, have this intense install, you're educating, showing, like thinking about it, but also you don't want them to have to rely on you after you leave, to your point, right?
Exactly. So, the better the education we do during those days, I mean, the more comfortable they do feel when I leave. And that's, the torch of eye tracking handing over from generation to generation, in a sense, like it's bringing everyone in to like, look at how amazing this is. Now it actually does work.
Yes. So let's talk about smart support. So what is it? Why keep up with it? How does it work? Can you talk a little bit about that and how it's set up?
Yep. So let's get the two very obvious things out of the way first. I mean, so having smart support, when you buy a system, whatever number of cameras you do buy, you do get 1 year of smart support included. And with the smart support comes hardware warranty. So if something breaks down during operation or whatever, we swap that out for you by, first of all, there's a slight investigation, like what is the camera? Sometimes you get like a question for a customer, like, the system is dead. What do I do? Like, all right, first of all, I was unaware it was alive to begin with, but let's see what's exactly, is the camera's black, or is it blinking, or like what is dead? What does it mean? But if anything broke down, and sometimes that's the case, because like some environments can be pretty rough, as we will see on some examples I sent you a picture of earlier. But the hardware warranty is obvious. And each year you prolong your support, you get new hardware warranty. And I mean, the cameras and cables and everything we do, they are custom made. So they can be pretty expensive if you buy them outside of support. So a lot of it comes actually down to, if something breaks down, if you have support, this is almost like insurance of getting new and proper stuff. And then we have the software release. Like, I mean, our dev team that creates our software for us works, I was almost supposed to say day and night, but they mostly work during the days. They do a tremendous work of creating new features and making the eye tracking and head tracking more robust and precise and all of that. So it's a living thing, obviously, like the software gets better and better. And if you stay on support, you get these new features and you get the added robustness and all of that. So these two are pretty obvious things: hardware support and the newer and better software. But the main thing, which my team represents, is even if it comes down to, yeah, your system just works, like there's no hardware problems, a lot of times it could be if the tracking isn't good as when we left you, for example, when the commissioning again, make sure that it works.
So the different examples of how you get in there, getting people set up, what the setups look like. So maybe we can start with your first one here.
Absolutely. All right. Yeah. So this is from an Air Force base in Alabama, and I went a little bit out of the way to not take the normal car situations that we do see a lot of times, because like that's more or less how our system came to be and how it actually works, is using it in car settings. So these examples would be something else. That doesn't mean that we don't do car settings, because that's actually absolutely something we did do. But in this Black Hawk helicopter, we deployed a 4-camera system. And why I liked it is because in a helicopter cockpit, there's usually very little space to find, to position cameras and cables, and making it so the tracking accuracy down to this tiny little level. So you can see there are a bunch of gauges and stuff inside that cockpit. Whereas maybe you want to see in the primary flight display, are you looking at the speed tape or the altitude tape, the artificial horizon, whatever object is inside the HMI displays. The one that does the study is usually interested in fairly small objects within this. And then within the helicopter, if this is a moving base, for example, there's a lot of vibrations and looking around. And to maintain the robustness of the system with some accuracy to actually see which different like levers or gauges you're looking at, that's a highly, it demands something from an eye tracking system that you wouldn't be able to do with any bar tracker or one camera tracker that is out there. Because this is, as a pilot, you actually are looking all around. There's a bunch of buttons all top, like the overhead display, and like there's a lot going on here. Which is why aviation stuff is kind of like my favorite, because it's like, adds a challenge to everything. And I think actually, if we move forward one slide, we can see this 3D model that we build for it. So this 4-camera system, this is kind of like, if you're able to see the 4 faces that is on top there is me sitting in the cockpit and like pretending to fly. That's what I'm saying. Like it's almost like a toy, because like if you sit in is an awesome moving bench flight sim, yeah, you can't have much more fun than that actually. But that, you see, the 3D model is the representation of the 3D world that we do deploy with the system. And that leads to the fact that with the data you get from the system, everything gets real-time tagged. So it's very easy to when you create a study, if you're looking at the primary flight display or the navigational display or the windows, whatever, all the data that you collect is actually tagged with the object that you're looking at. And you can subdivide this object down to very tiny pieces. And it makes everything like very, very easy post-install to actually read the data, what's going on in the timeline of your studies. So that's why this type of example is like awesome when we see that we can deploy a system with, it's like super complex, but reading the data is actually not that complex when you understand that we have this 3D world that is represented in the software.
Very cool. I love how you can see both, like how you set it up, and then you can see the view of.
Yeah. For this one, I actually added it because when we talk about the 3D world model and why it's important, if you don't have this image, it's kind of like hard to understand what's a world model and why does it matter. But if you are versed at all within eye tracking, you would absolutely understand what this makes a huge benefit when you look at the data later on. Because if you don't have this, if you only have vectors coming out from your eye and saying, I'm looking at this degree over here and this degree over here, like how am I supposed to know if that's the navigational display or the primary flight display? And even getting down to, I think further down the road, we have some slides showing some the accuracy we have in the system sometimes. And you can see that when we go down to the nitty-gritty level, sometimes we actually want to see, subsections of a screen or something. And to know that by only saying the vectors and where they gaze in an environment without having objects is very, very hard to know how to use that for some actual interesting data.
Yeah, absolutely. Let's look at the next one. I think this is a train simulator.
Yeah, so these are moving-based train simulators. So you see those white boxes on the most rightmost screen.
Yeah.
Those are actually like small rooms. It's almost like a little hut or something on moving legs. So the picture you see on the left, which is actually inside of a train, that's the cockpit being inside each of these white boxes. So that moves and vibrates and everything because it's a train sim. And here it's used to train, and I learned this the other day, that they are actually called loco pilots. The guy that drives the train, they're called loco pilots. So when they're about to train or educate and, certify someone to drive a train, this is from a Polish sim creator that's called SimFactor. And they work with CTK to create this pilot training software to train them. So it's very easy for an instructor, after saying, you have your driver test, so to speak. Are you supposed to be a certified loco pilot? So they gives you a bunch of scenarios, and afterwards the instructor can say, you know what, you didn't look at that sign when we left the whatever thing, and you supposed to look at the speed before you brake, or there's obviously a bunch of stuff that you need to do when you become a loco pilot. The instructor could then follow up and say, it took you a little bit too long before the warning lamp started to blink. You didn't look for it for the first 5 seconds or something. Because the eye tracking gives you this possibility of, knowing exactly where are the attention of the loco driver in this perspective, to actually train and educate loco drivers. And the picture in the middle is just how I love. Now, if you go back one, that middle picture, it's like how well integrated into this environment. So this camera with its illumination and everything that we looked at is now behind that panel, and it's rotated in this little ball mount. So when you step into this train sim, in that sense, you don't see cameras, you don't see illuminations, you don't see that there's an eye tracking system there. And that's kind of like, the definition of being in a remote system, that you actually don't even know it's there. So you can just go in, drive the sim, do whatever you're supposed to do as a loco pilot, but the instructor have this tool of giving you all the data you need to know about the driver and the attention of the loco pilot.
Right. It's very, very and it like fits. You don't even think about it, like you said earlier.
Exactly. And that's why, of course, we call it non-intrusive eye tracking, because that's literally what it is. Yeah.
Makes sense. All right, let's go to the next case study, which is really cool. I know we work with a lot of universities, so I'd love you to take us what this setup was.
Yeah, so this was in Canada, and they wanted to do these very long drives. First of all, to see how's the attention level in the beginning of a drive and how's the attention level at the end of the drive. So this was supposed to, be 7 or 8 hour drives. And what really is, because normally a study that people do maybe in Easy Simulator or something could be anything from, 10 minutes up to an hour. But usually they're chopped up in different segments, and you always, or most of the case, you have the opportunity to calibrate the system or make sure that if something is out of sync or something, you can always rewatch that, begin again, and it's you have these time slots of data that you can look at. But if you're about to say I'm going on a drive in this truck and I'm driving for 8 hours, it's very important that the system keeps performing as well at the first 20 minutes as the last 20 minutes. And it can even be the case that the last 20 minutes is actually the most interesting, because that's actually when the driver starts to get tired or maybe inattentive or something. And in this case, they only had like a 20 minutes gap between one driver stepping out and another driver stepping in. So everything needed to be very, automated in the sense it should just work. And I mean, that is something for a support technician when something's like, oh, we need a system that just works. And I mean, it does every time if you do everything right. If we're there, everything always works. Like that is literally what it is to be a support engineer.
Yeah.
But that's not always the case in real life. So we needed to make sure that we have a robust installation enough to survive, driving and driving and driving, doing what you're supposed to do. And in all of these environments, there's a lot of vibration. There are temperature changes. Like there's a lot going on. So to do these installs. Exactly. Yeah. So you see in the first image, the leftmost image is we actually have to bolt everything there. And there you see an industrial PC, which is designed to withstand a lot of vibration, like real live scenarios. And it works on the power outlet from the truck. And it's very hard to see, but in the rightmost image, there's the cable management that we have to do from the dashboard down along the, carpet inside, because if the drivers go in and out of this truck all the time, there can't be cables, hindering the movement and everything. So we needed to hide everything really, really well. So in that sense, looking at the cameras, they weren't as nicely hidden as they were in the train simulator case. But here instead, we needed to work a lot with cable management and bolting everything, and everything would needed to be really, really robust to, survive day and night, just driving this truck. So this was an interesting challenge of making everything easy for the operators, but also robust and keep accuracy going and going and going.
Awesome. Very cool. So we got one more case study for you. I know this is a farm equipment tractor situation.
Yeah, exactly. I don't know the word for it, but it's one of these tractors that, plow and actually sows the seeds or something. That was at least this. Exactly, the plowing but with a tractor. Because like when I hear the word plow, I was like, I'm back in 17th century, behind the ox or something. But yeah, exactly. And I think it moved slightly forward from that. But and this, of course, is also one of these scenarios, because what they do in this tractor is, of course, they drive the tractor and they're looking outside. Where are we heading? But as soon as you have a heading, there's not much going on the field. Like you're just driving straight forward. So what they do is they rotate. So they always look backwards on the actual, there's this thing that they have behind the actual plow is the tractor plowing. And that's super wide and consists of, I don't know, like 20 or 25 big scoops that's, shovels dirt or something.
Okay.
And they wanted to know which one of these plow thingies, like almost like a spade connected to something, which one of those am I looking at, and how am I spending time on looking backwards and forward? There's a lot of equipment inside this tractor that gives you a lot of data. So we needed to track like the driver obviously looking. Are you looking at the mirrors? What are you doing? Then turn around, you look at the different plow sectors, you look at the instruments, and how much time do you actually spend between looking at the instruments, looking at the real time, plowing backside? How much do you need to look forward to not, steer away or something? I don't exactly know what they were doing, but this was the challenge of having this full field of view from tracking outside, which is normally the easy thing, because like we do that all the time. But you, as a car driver or a truck driver, you rarely turn around to look like for several minutes backwards and then going back again. And we tried to do this with a 3-camera system, and you can kind of in the image see where I deployed them. So the blue balls is kind of like where the cameras are supposed to be, and the yellow balls are the illuminators for our environment. And here on the yellow text box, you can actually see the level of accuracy that we achieved on different instruments. So even driving around on a field, like everything it's jumping and doing, this is a really hard case to actually do something real good. And after several minutes, we could still see for the left and the right eye, our accuracy levels is a lot of times it's like beneath 1 degree accurate. And that's like, I need to save these numbers because that's amazing. I was so proud when I did
Can I
this.
ask a clarifying question? What is the difference?
Absolutely.
What's the difference between accuracy and precision?
Yeah, that's a very, very good question, actually.
They seem very
So accuracy, we kind of describe that is, let's say I'm looking straight into the lens of this camera.
Yeah.
If I'm looking 5 degrees to the left of this camera, that will be me missing accuracy. So if the system says like you're looking on another point, that's less accurate. So think about a bullseye on a dart or something. If you dead center, that is the best accuracy. But due to nature of eye tracking, the gaze vector seems to always be like vibrating or shaking. And if you have bad light conditions or the flash, like bad calibration levels, maybe the cameras have moved, or you lose some accuracy. A lot of times you also lose precision in the sense that maybe the bullseye is in the right center. So the average of all these data sectors is in the middle of the bullseye. And let's say that your dart is up to 10 points, let's say. So all of the outer ring of your dart, let's say that is 0 points or 1 point or something. If you had bad precision, your gaze vector would bounce all from 1 point to bullseye to 5 points. So it's very random where, so your average could still be accurate, but it's very bouncy and jumpy. But if you have low precision, a low number within precision, that vibration is also like you are still within bullseye and you're really like dead on bullseye. So if you have high precision, like low numbers, you can still be off in accuracy, but the precision could be high because like you can be off the target, but very, distinctly non-vibrating. So that's why we do this distinction that accuracy is actually your direction is correct, but it could be a little shaky.
Okay.
And we want these numbers to be low because they are expressed in degrees. And like 0 degrees is like, then it's perfect.
0 degrees of accuracy, 0 degrees. Okay. Perfect. All right. I think that was our last case study, but I know we covered a ton of stuff today. I just wanted to give you a chance to recap, like, what are your top takeaways for everyone watching this presentation?
Yep. Yeah, of course, you sent me this question a couple of weeks ago. I was like, well, what you want them to take with them after a session like this when we do talk with the customer and stuff. And the first thing that came to mind, and this is so stupid actually, but this perfectly encapsulate how I think that we work on support at Smart Eye, because you'll never work alone. You never walk alone is the song my brother used to play because he's a Premier League fan and his favorite team is Liverpool. And they have this song that is called You'll Never Walk Alone, Walk Alone. And that's how I see my relationship with the customer, because I always want the customer, when we leave them and we have established over a couple of weeks or a month or whatever, this type of relationship that we have visited their places, they know who we are. And whenever they feel that something came up, maybe, the accuracy is just slightly off, for my message to you as a customer is literally, you'll never walk alone. Like, come to us. We will always be able to find like, okay, I hear you. Let's see why the accuracy isn't as good as maybe it was when we left you the first time, or maybe we can come back and look at it again. The main thing is when you are under smart support, you don't necessarily have to have a broken system to get in contact with us. We can always find, ways to find better data. How should you interpret the data? What could be a better way to go about if you're redesigning your study? So a lot of customers, they buy a system to do a certain study, and then they maybe need the system for another situation or an environment. And that's when you need to reevaluate, like, okay, should we now maybe move some cameras in a new position to do this new study? And we're always here to help with that, take some decisions, because we see a lot of different installs, as you see. That's why I think it's so important that we that work at support are also the guys that do the install, that meet the customers, that see the actual environment in the end. So it's very important that otherwise we lose contact with the system. So we need to be the one that is out in the world, seeing the system performing in real. Then it's way easier for us to help the customer actually achieving that goal. If we were only, desktop warriors sitting in mailings like, oh, you should pull this cable and you should do this, press this button. We need to really, in the bone of it, understand our system. That's how we can help you. But then again, of course, as soon as you have problems, maybe you have a blinking camera, or maybe you destroyed a cable, because like everything can break down, even the best designed system, and especially if it's so like advanced and delicate as our system actually at the end is. There, you will always be able to break it. With some unlucky, you can just hit the lens here, and maybe this IR filter cracks or something. We can supply you with a new one. So, I mean, the obvious things, as I said, hardware and software, that's the easy part. Let's just provide it. But it's understanding the system in your environment. That's where we thrive, and that's where we can be at the absolute most help. And the most tragic thing I see sometimes when I revisit the customer, I see like a box in the corner somewhere. It's like, what's that? Yeah, that's a system we bought like 3 or 4 years ago. We don't know how it works. Like, no, you shouldn't let it sit in a box over there. Like, let's pack it up. Let's do something with it. So like that's why number 5 there. Like, don't get stuck, because like if anything, like, you just need to redo something. A lot of times, especially universities, as you say, we work with a lot of universities. Sometimes students comes and goes. They write the master and they move on with life. They have new students coming in. We can come on site, do a training again for the new students, new generation eye trackers, and making sure that their equipment, which is awesome, most of the time, there's nothing wrong with old cameras or old computers. They also work just fine. But making sure that knowledge stays within the parameter, or the organization, we can come there, train again, customizing it, adapting it to their new setting. And that's why, like, don't get stuck if it's like, we don't get image on these cameras. Even if you're not on smart support, make sure to contact us, because we will probably be able to help you. And then you can jump on the smart support program again, and for a little fee, of course. But we're always here to help. That's the main getaway. Like, I mean, that's very important for me, that you feel welcome to talk to us. We'll be happy to.
Nice. So I think this was a great discussion, super fascinating. I was wondering, on the topic of, ensuring customers have access to the assistance that they need, how do you advise people like our customers, how do they best contact us, or what's the parameter that is set up in order to interface with the customer?
Yeah, easily by getting in, send an email to support@smarteye.se, as you write there. Support@smarteye.ai, I think it works as well, because it's a little more fancy address when it ends in AI. But support@smarteye.se, that's our main contact. I mean, that's usually how everything starts. And from there, when we understand the situation or the problem, whatever, we normally want to jump onto a call, maybe. It could be any digital platform, but it's so much easier to actually talk with the person, like instead of sending 1,000 emails back and forth. If that's your way, we'll be happy to just bounce emails as well, or chat, or whatever you want to do. But in my experience, it's actually easiest to jump on a call. If you have the opportunity to maybe, broadcast a screen sharing from the computer that actually does the tracking, we can see a lot of it. We see the focus. We can see the problem. But it saves everyone a lot of time if we have the opportunity to just see that in a call. But like everything that works for the customer, Morse code, like I'll have to learn it take a little extra time, but we'll be happy to
get there eventually, right?
Exactly.
Another question I had come in was, and I don't know how much you know about this, but how would you say in terms of, competitive different, like how do we differ from smart support with other kind of standard support services? I know we've touched on a lot, but I don't know if there was anything you wanted to add in terms of what we're able to provide.
Yeah. First of all, we're just better. That would be one thing. But I mean, I don't know how other eye tracking companies like do support and stuff like that. But I can imagine, since our product is, so here's the thing: we are pretty alone in the world of doing multi-camera remote eye tracking systems, and it could fairly quickly become complex. So I know we struggle a lot with misalignment of cameras, for example. If you have a camera placed here and you have a camera placed here and they accidentally move, I mean, that's very bad for tracking accuracy. So when it comes to mounting stuff and all of that, it means that we need to understand so much more and intricate how our system performs and how it works to actually be able to see, like, okay, this looks like a problem that will be due to this factor or that factor.
Mhm.
So that's a pretty unique situation, which also leads me back to the fact that that's why it's so important that we are the people that also do the installations. Because when we have some very, very few customers that actually buy the system and say, you're not allowed inside the perimeters, it could be secret, whatever, and they try to deploy the system themselves. And it being on your own is actually very, very hard when it comes to this type of product. So we probably differ in the sense that nothing is actually easy. But if you understand what you're doing because you're following our guidance and we are here for you, it doesn't have to be super hard. But if you are trying to do it yourself, that could actually be pretty hard. And I of all the different technology aspects that I've encountered, I mean, as I said, I love technology, home cinema, computers. I build stuff like I do, and I rarely come across a system that is so non-plug and play as our product.
Mm.
And that is not to say that it's just hard to do. It's just that you need to know a little bit about it when you set it up. And that's where we come in. We transfer that knowledge to you. So building your own computer, that is not that hard when you know what to do. But if you have no clue, I would bet it just feels like, oh, here's a bunch of components. What should I do with them? Like, where should everything go? So that's the value of knowing us, because we can help you get the most of it.
Awesome. All right. I have one more question I'm going to squeeze in, and I think you probably touched on, but I wanted to give you a chance to expand. So, on the topic of customization, how flexible are Smart Eye solutions in terms of adoption to fit specific research or business needs?
We can do everything. We can probably do what. Throw anything at me. We can do it all.
Sales,
But I
look
mean,
at them go.
that is the ultimate challenge, of course. But we take a lot of pride in that. That's why it is so highly customizable, and it's a bunch of cables and multi-camera and everything. But reaching new stuff, and that's why it's so awesome to visit some customers when they present this crazy idea, like, do you think we can do this? And someone is hanging from a rope in the ceiling and wave, like, wow, that sounds insane. But yeah, if we put cameras maybe here and here, and I would say it's so highly customizable that I have not yet really come across a situation where we just had to say, you know what, that is insane. The only thing I would say, though, is if you need something where you move around too much. So that is so we have a remote eye tracking system that we deploy in the environment. But let's say you have a marketing study and you're moving through a shop and you want to know, like, you're looking here over where all the milk is in the shop, and you move, here is all the bread, and which brand of bread are you looking at? You will never deploy a multi-camera system because you're moving around in the shop. There's actually one of very few cases where it's better to maybe have a wearable or something like a pair of glasses that track the environment. But then you lose all the benefit of having, live tagged data and post analysis and all of that.
Yeah.
So in cases where you move around very, really get away from the system, then we do fail. But every time you have a driver, you sit by a desk or a table, a pilot, like anything, when you operate something, we can absolutely find a way. We always do.
Very cool. Well, that is all we had time for. I want to thank our presenter, Emil, once again for making the time to speak with us today, and all of you for attending and for your great questions. Hopefully, this gave some clarity on customer support that Smart Eye provides. We will be sending the recording out shortly, so you can reference it back. But please reach out to us, as Emil mentioned. In the meantime, if you have any questions, definitely follow us on social media or sign up for our newsletter so you don't miss our next virtual event. And thank you, everyone, and have a great rest of your day wherever you are in the world.
Thank you.
It was such a pleasure speaking with Emil around all things customer support. What most resonated with me was that while our eye tracking systems are comprehensive and cutting edge, setting them up and working with them doesn't have to be daunting. In addition to our sophisticated eye trackers, our team understands that customers will be successful if they get the customized support and the guidance that they need. I hope that you enjoyed today's episode. Don't forget to subscribe to our Human-Centric AI podcast on iTunes, Amazon Music, Spotify, wherever you get your podcasts for new episodes. We are also on social media, so please reach out to us on X, formerly Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.